Now we will learn the image formation by a concave mirror. But to understand this concept, we must understand every rules which we studied to draw the ray diagram for concave mirror. So we studied four standard rules where the ray was traveling parallel to principal axis, it was passing through F, it was passing through C, and the ray incident at pole of a concave mirror. So using all the standard four rules to draw the ray diagram for concave mirror, we can study the concept of image formation by concave mirror. And now let's study the possible positions of object that can be placed in front of a concave mirror. So what I have considered a concave mirror, I have marked point P, F, C, okay, and every time see on a diagram I have placed the object which is perpendicular to principal axis. Remember, whenever you are doing image formation by a concave or convex mirror, the object should always be placed perpendicular to principal axis. So there are 6 possible positions for the object that can be placed before a concave mirror. First is the object placed very far away from the mirror. So we call it as an object at infinity. Sometimes the object is placed just beyond C, or you can say between infinity and C. It is placed object beyond C. You can place the object at C also. This is the third position where object is placed at C. The object can also be placed between C and F. The object can be placed at F, or the object can be placed between F and P. And the last one, the object placed between F and P, also called as object placed within the focal length of the mirror. Remember, for the formation of image of each object, you have to construct mirror by a proper method. I have already explained you that in your notebook, use your reference line. Use any one of the reference line as the principal axis. Mark C over there. Take 4 centimeter in the compass. Okay, and you taking 4 centimeter, you can construct a concave mirror, 3 line above and 3 line below the principal axis. So this will give you a proper concave mirror. And remember, mark P, mark F exactly between C and P, that is at 2 centimeter, because CP, that is radius of curvature, we have considered as 4 centimeter. And any object you draw should always be perpendicular to principal axis. And remember, here your object should be of the height of 2 lines. That means 1 and 2, every object should be drawn of the 2 of size 2 line. Now let's start with the first case where object is at infinity. Object is placed at infinity. So we have two cases over here. In one of the case, the incident rays should be coming parallel to principal axis, or the rays should be inclined to principal axis. So if I consider the first case where the incident rays are traveling parallel to principal axis, this will be very simple. So what I will do, I will draw these rays to be coming from infinity, because from infinity the rays are always coming parallel to each other. But here purposely I have taken that these rays are traveling parallel to principal axis. So definitely after reflection, we know this rule that if a ray travels parallel to principal axis, after reflection will definitely pass through F. So here you can see that the rays are meeting at F. So where is the image formed? Come on, tell me. At F. Is it formed due to actual intersection? Yes. The image is formed due to actual intersection of the rays, because the rays are actually meeting at F. So the nature of the image will be real. Since it is real is always inverted, right? And third case, if I talk about, we have got a point image. So this is highly diminished, because point image we call it as highly diminished. Remember, whenever the image is formed of the point size, it is highly diminished. So in first case, the rays were traveling parallel to principal axis. But what if the rays are traveling inclined to principal axis? You can say this rays, say one of the ray here, okay, and let's say other rays pass through F. and other rays make it pass through C, let's say. So we know the standard rules over here that if the rays are traveling parallel to principal axis, it will meet at F. But if they are traveling inclined to principal axis, they will meet at a point on the focal plane. So I will use the standard rules over here that, see this rule, this ray, can you see? I will name it as 1. So one ray is passing through C. So definitely this ray will retrace the path. Okay. If we talk about the next rule, which is passing through F, then definitely after reflection it will travel parallel to principal axis. So it will travel like this. Then definitely this is the incident ray, this is the reflected ray, this is the incident ray, this is the reflected ray. So that means we have already obtained the location of image. That means where is the image formed? At the focal plane. And remember, this will be the image. This will be the image, and you can see the arrow is downward, that means image is inverted. You can also ask me, sir, why have you drawn third ray? Third ray can be completed by simple ray diagram, that if it is incident at pole, then definitely it will get reflected on the other side of principal axis with the same angle. But here no need to measure the angle. You can directly join this point with the arrow, okay, and the image is formed over here. Remember, for each and every ray, okay, for incident ray you have to draw arrow, for reflected ray you have to draw arrow, otherwise your marks will be deducted, or sometimes you might get 0 mark, right? So this is the image. So where is the image obtained? At F, or I can write it at focal plane, right? And this image, you can see the image is coming from infinity, that means object is located at infinity, which can be of very big size, but the image we can see it is of finite size, very small. So still you can write it highly diminished. Nature is still the same. It is formed due to actual intersection, so it is real, inverted and highly diminished. Now we have the second case where object is kept beyond C. You can see the object AB placed perpendicular to principal axis and is kept beyond C. Now let's locate the image by the rules. So one of the ray every time you can use is ray passing parallel to principal axis, and after reflection will pass through focus, and other passing through F and then will travel parallel to principal axis. So the standard rules, if I consider, so this is the rule which says that ray traveling parallel to principal axis and then after reflection will pass through F. So I have drawn a standard rule. Other rule I can consider that ray passing through F, ray passing through F and after reflection will travel parallel to principal axis. You can see this being the incident ray, reflected ray, incident ray and reflected ray. Definitely we have obtained an image. Okay, so this is the image, and image is always drawn perpendicular to principal axis. So this is the image which we have got, right? So I would name image A1 and P1, right? We have used, remember, only 2 rules to draw the ray diagram. Remember, all 4 rules can be used simultaneously, but the diagram will be very complicated and you might not get the image at the same point, even due to some fractional error. So remember, use only 2 rules unless it is specified a given rule, that draw the image using the rule passing through C or passing through F or passing through P, or you can say passing parallel to principal axis, right? So here I have obtained basic 2 rules to get the image, and where I have obtained the image between C and F. So if the object is placed beyond C, what is the position of image? Image I got is between C and F. Can you see? Is it formed due to actual intersection? Yes. And remember, in case of mirrors, if the image is formed in front of mirror, if it is formed in front of mirror, the image has to be real image. If it is formed behind the mirror, then it has to be virtual image. So definitely this image is real, inverted, right? And if you draw it on your notebook, you can clearly see that the size of the image will be smaller than the size of the object, and here also you can see the image seems to be smaller than the object. So I will use real, inverted, and then diminished. Okay. If I talk about the third case, we can say object is placed at C, and remember this rule sometimes you might not get, because I will directly give you the answer. Because if the object is located at C, the image has to be located at C, and here since the image is obtained at C only, it is formed in front of the mirror, definitely the image will be real, inverted, and in this case the image will be of same size. Again, as I said, even due to a fractional error, the image will not be obtained at C. I will give you a rough diagram. See, this is the mirror I have talked. I am not taking any actual construction. This is just a rough diagram. P, F, C. I have taken an object and the ray traveling parallel to principal axis passing through F, passing through F. What you have seen that the image is located between C and F, but in fact this is wrong. As I said, even due to a fractional error, you might not get image at C. So what I will suggest you guys, that if you drawing the object at C, simultaneously you draw the image at C. See, this is just to get a proper construction, or if you have used a proper construction, then draw it once to get the image. Even if you practice 2 or 3 times, because my center of curvature is not exactly the same. This is just I have considered a mirror and I have marked C and F randomly, but when you draw it properly on your notebook, you will definitely, your center of curvature will be the actual center of curvature of the mirror, where you will locate the image exactly at the C. So what rule I am using over here, it is passing through parallel to principal axis, then definitely will pass through F, right? Another is passing through F, right? Then definitely it will travel parallel to principal axis. You can see this is the incident ray, this is the reflected ray, and I will mark F over here. This is the incident ray, this will be the reflected ray. So image I obtain as A dash and B dash. So where is the image exactly obtained? At C. Where is the object? At C. What is the nature of the image? It is real, inverted, and same size. Now let's talk about the next case where object is placed between C and F. So I have drawn a mirror and I have located an object between C and F. I have to use the rules to draw the ray diagram. What rule I will be using? That the ray is passing parallel to principal axis and after reflection will pass through F, right? If I talk about another rule, see, this is passing through F, okay, and definitely after reflection will travel parallel to principal axis, and if I locate the image, you can clearly see the image which I have got is beyond the center of curvature. I have used the basic rules: parallel, passing through F, right, and then parallel. I have got 2 rules. So where is the image located? Image is located, come on, tell me, beyond C. And what is the nature of the image? Is it due to actual intersection? Yes. It is formed in front of the mirror, right? So definitely the image must be real. It is inverted and now it is bigger than the size of the object. So it is magnified, right? If you remember, I have explained you principle of reversibility of light, which says if objects, if incident ray becomes reflected ray, then reflected ray becomes incident ray. What I mean to say that we studied that if the object was kept beyond C, remember, if the object was kept beyond C, the image was between C and F. That means if the object is between C and F, the image will be beyond C. That means here object and image distance can be easily interchanged. That means if this is the object and this will be the image, then if it becomes object, then this will be the image, right? So real, inverted, magnified. In the second case or in the fifth case, I have placed object, come on, tell me, at F. So what I have to do? I have to consider the rays parallel to principal axis. So one of the ray I have considered parallel to principal axis, right? Other ray you can pass it through P or you can pass it through C. See, you can see here that if I take this ray, right? Let's mark C first of all over here. So if I consider a ray through C, ray coming from object, right? This ray comes from object and will get reflected from the mirror. In such a case, see here, right? So the ray coming from the object will incident on the mirror in such a case that it seems to be coming from C. That means the incident ray is somewhere passing through C only. Then definitely it will retrace the path. So this will be the reflected ray. You can see. So this is the incident ray and this is the reflected ray. So what I have got? I have got two parallel rays, right? And these rays will meet at, come on tell me, at infinity. That means if the object is at F, the image is formed, come on tell me, at infinity. Definitely here the image is formed in front of the mirror. Here we consider that parallel rays will meet at infinity. So I have to take this image as real. Real is always inverted, and since the size of the image will be very large, it will be here highly magnified. If you can remember the case where object was at infinity, where was the image formed? At F, and now the object is at F, so image is formed at infinity. This is only due to principle of reversibility of light. Now let's consider the last case where object is placed between F and P. We call it object placed within the focal length, or we have to say the object is placed very close to mirror. So whenever object is placed very close to mirror, definitely object will lie between F and P. You can call it as object located within the focal length. Now using the simple rules to draw the ray diagram for concave mirror, one of the ray will travel parallel to principal axis. After reflection, it will pass through F, right? Incident ray, reflected ray. Other ray you can take through C, like in the previous case. Like in the previous case, I explained you that the ray will come from here and it will appear and it will pass through C. So this is the incident ray, this is the reflected ray. See here we have got divergent rays. Parallel rays can meet at infinity, but divergent rays will never meet anywhere. So what we have to do over here is to extend these rays, or we have to take these rays backward. So if I take these rays as backward, what I will find out that when I take these rays backward, the dotted rays are meeting at some point. I'll draw it again. Here, when I trace the rays backward, they are meeting. You can see they are meeting at some point. That means they are meeting somewhere over here. So this is the point where the rays appear to meet, and it is lying behind the mirror. So if I draw the image, see, I have to draw the dotted image. Remember, this is not an image of the entire line. In fact, this is not the real image. Since this image is formed behind the mirror, it is A dash, B dash. So what is the position of image? Come on, tell me. Behind the mirror. Tell me, is it due to the actual intersection of the rays? No. Here the rays are appear to meet, right? So definitely the image has to be virtual. Virtual image is always erect, and we can see that the image is of bigger size than the object, so it is magnified. So the last case which we have studied is very, very important for application of point of view. It is the same applications where we talk about the dentist mirror, we talk about makeup or a shaving mirror. That means whenever we use a mirror for shaving or makeup, what we do, we keep the object very close to mirror, right? That means whenever we keep the face very close to mirror, our face lies within the focal length of the mirror, which forms a virtual, erect and magnified image. Here image virtual is not important. What is most important is that the image is erect. That means it will not create any confusion between us, because for us if the image is inverted, it will be of very confusion, right? Here the image is magnified, right, as well as erect. So it is very helpful for us. So whenever we talk about a makeup mirror, shaving mirror or a dentist mirror, that means whenever a dentist want to see the cavity in the teeth, he uses a mirror which is a concave mirror. He put this concave mirror into the mouth of a patient and he can clearly see the cavity to be a bigger in size. So remember, this application has got very important, and it has so many applications. So whenever questions comes on dentist mirror, shaving mirror or makeup mirror, remember it is always a concave mirror, and that too when object is placed between F and P, that is within the focal length. Thank you.